Hello, viewers. In this video, we'll be solving these four interesting problems. Question number one says if P and Q are solution of the quadratic of the equation x bracket x minus 2 equals to 2 bracket x plus 4, we want to find the value of P square plus Q square. While question number two, find the x-intercepts of the line passing through the point minus k 3 and perpendicular to the line k plus 1 or bracket x plus 3y equals to minus 4, with the restriction that k cannot be minus 1. Then question 3 is about complex numbers. So you have this complex number z is the cube root of minus 8 multiplied by the square root of minus 20 divided by the square root of minus 5 plus, then here you have 1 minus I over 1 plus I all to the power 75. I is the square root of minus 1. We want to find the sum of the real part and the imaginary part of the complex conjugate, z bar. And question number 4 is find the values of m for which this quadratic equation has one root. So let's get started with question number 1. So question number 1 is asking us to find the value of P square plus Q square. So the first thing we can do here is just to expand this so that we have x squared minus 2x is equals to 2x plus 8. And we will have x squared minus 2x, then minus what? Minus 2x minus 8. This will be 0. So this is x squared minus 4x minus 8 is equals to 0. So we can try to factorize this to get the solution, or we can use factorization. We can try factorization. We can try either completing the square method, or we use the quadratic formula. But now if we try factorization, it means we need to get two factors that will give us what? Minus 8. And when you add, will give us what? Minus 4. So it's difficult to get such factors that two numbers that you can multiply to get minus 8 and add to minus 4. So it means we have to think of something else. We have to think of either completing the square method or using a quadratic formula. But this question is asking us to find this P square plus what? Plus Q square. So we'll try to be smart about this by using a different approach. We take A to be what? 1. We can take B to be minus 4. And we can take C to be minus 8. So what do we know about the sum of solution of a quadratic equation is given by this formula, minus B over A. So this will be minus 4. So this will be minus minus 4. All over A is 1. So this will just be 4. And we can get the product also. P times Q is given by C over A. And what is C? C is minus 8 over A, which is 1. And this will give us what? Minus 8. Okay. So what next? We're looking for this one. If you remember from, I think, polynomials, we can have this fact. We can expand this as what? P square plus what? 2PQ plus Q square. So now what is P plus Q? P plus Q here, it's 4. So this is 4 square. It's equals to, now this is P square. We don't know what it is, but we know what is P times Q. So P times Q is minus 8. Then we have plus what? q squared. So this is 16, and this is p squared minus 16 plus q squared. So we can transfer this to this side. So we have 16 plus 16. Then on the right hand side, we're left with p squared plus q squared. So we have 32. It's equals to p squared plus q squared. So that is it. So we can rewrite it as saying p squared plus q squared, it's equals to 32. Okay. Now we move to question number 2. Question number 2 is asking for the intercept. It's asking us to find the x-intercept. So the x-intercept simply means what? When y is equals to 0. That's what it means. So the x-intercept of a line passing through this point and perpendicular to this line. So we can easily find the slope of this line by solving. So we can rearrange and say this is 3y is equals to, we can transfer the whole of this to the other side. So we have minus 4. And now we have y is minus k plus 1 over 3x minus 4 over 3. So this is now in the slope intercept form. So slope, this is what we call the slope intercept form of a line. So we can get the slope from here. So let's call the slope m2. Yes, let's call it m2. You can call it m1. So this is minus k plus 1 or 3. Now, but we're looking for what? We're looking for a line. There is a line here which passes through this point. And we have that it is perpendicular to this line. So what do we know? So it means the slope of that line, let's call it m1, is going to be the negative reciprocal of this, since that line is perpendicular to this one. So this will just be what? It will just be 3 over k plus 1, right? Because the negative will go. We know that if two lines are perpendicular, then the product of their slope will have to be minus 1. Now, we will use the slope, let's call it m1. And also we have a point already given, which is minus k and 3. So we will use this information to find what? We'll use this information to find the equation of this line, because we don't have the equation of the line 1 yet. Okay, so how do we do that? We use our, what we call the point slope formula, because now we have what? We have a slope and we have a point. So this we write as y minus y1 is equals to m1, then x minus what? x1. So this is the slope and this is the point. We can consider this as x1 and y1. So then this will become y minus 3 is equals to 3k plus 1 into x minus, what is x1? x1 is minus k, so this is minus k is going to be plus k. Okay. Now, this is now our equation of the line, but we are looking for what? We are looking for x-intercept. And what is x-intercept? X-intercept implies that y is equals to what? 0. So let's go ahead and plug y equals to 0 into this equation. So this becomes y equals to 0. Here become go. So we just have minus 3 equals to 3 k plus 1, then x plus what? Plus k. Now we can cross multiply so that you have minus 3k plus 1 is equals to, this will just be 3x plus what? X plus k. Now clearly we can drop 3 and 3. So here we just have minus. So if you expand, this minus goes into this bracket. You have minus k minus 1. And this would be what? X plus k, right? So let's finish it here. What we can do here is we can try to write um, minus k minus 1 minus k is equals to x. So this is minus 2k minus 1 is equals to x. So it means that our x-intercept is going to be what? It's going to be, our x is minus 2k minus 1, and the value of y is what? Is 0. So it depends on what is the value of k. So this is just like a general intercept. Now, for different values of k, now you will get what? Different x-intercepts. Okay, and think let's move to the next question, which is question number 3. Now, question number 3 is a complex number. So we'll try to rewrite this first to simplify this in standard form. Remember, the standard form of a complex number is z is equals to what? A plus what? Plus bi, where a is the real part and b is the imaginary part. And from this, when we have it in standard form, we can now find the conjugate, which is just z bar, right? Which will be just a minus bi. So let's get z first. Now this z we can write as, this is the cube root of minus 8. So cube root of minus 8 is minus 2. And this we can write it as what? Root of 20i, it's fine. And this we can write it as what? Root of 5i, because we know I is the root of minus 1. Now plus, here, inside here, we can just try to what? So here you can say, okay, 1 minus I to power 75, but to deal with that, it's going to be very tasking. So better we rationalize inside. This is division of complex number. So we rationalize by the conjugate of the denominator, right? This is the denominator is 1 plus I, so you multiply by 1 minus I, which is the conjugate. Just change this plus to minus. So the z now is going to be minus 2. Root of 20 is just going to be 2 root 5 I. And here you have root of what? 5i. Plus, this now we can expand. 1 times 1. This is 1 minus I. Minus I times 1 is another I. Then we have I times I. So this is plus I squared. Then you have 1 plus I multiplied by 1 minus I. This is difference of 2 squares. This is just 1 square minus I square. But everything to power 75. Now here, root 5 will cancel root 5. Even I will go with I. So from here, you just have minus 2 times 2, which is just minus 4. Okay, plus here, this will become 1 minus 2i. I square we know is minus 1, so this will be minus 1 over, this will be 1 plus 1, because we know this is I square. I square is minus 1, as you can see from here. If you square both sides, you will get I squared is minus 1. So this is over 75. So this is minus 4 plus this. What we can do, you see, this 1 will go with this minus 1. So in here, we are left with minus 2i over 2, still to power 75. So we have minus 4 plus 2 will go with 2. So we just have minus I to power 75. Okay, to power still outside. Now this is minus, so this is an 75 is odd number. So this minus can come out. So we have minus 4 plus becomes minus I to power 75. Okay, now what is I to power 75? Powers of imaginary number. If you have I to power n, is the same thing as what? I to power r. What is r? R is the remainder you get when you divide n by 4, right? So we just need to divide 75 by 4, and this will give us about 18, right? Yeah, this will give us about 18. So the remainder is going to be, the remainder will be around 3, right? So this is minus is the same thing as I to power 3. Why is it I to power 3? If you divide 75 by 4, you get about 18, and you can see that if you said 18 multiplied by 4, this will give you 32. You would take 2, and this will give you 72, right? So you have a remainder of 3. So that's why we have I3 there. Okay, now, but what is I3? We know that if you have I to power 3 is the same thing as I to power 2 times I, and I to power 2 is minus 1. So you just end up having minus I. So this is minus I, and this will be minus 4 plus I. So this is our z. So the z is just minus 4 plus I. So what does it mean? This means that what? It implies that z bar, which is the conjugate, will be minus 4 minus what? Minus I. So if you have a complex number in standard form first, so this is the standard form, then now you talk about the conjugate. So the question asks us to find the sum of the sum, don't forget the sum of the real part and the what? The imaginary part of the complex conjugate, z bar. So now let's talk about the real part. What is the real part of this complex number? So here you can see that the real part of what? Z bar is just minus 4, while the imaginary part of z bar is minus 1. So the sum is simply minus 4 plus minus 1, which is minus 5. Okay, so we go to the final question, question number 4. Question number 4 says, find the values of m for which this is quadratic, has what? Quadratic equation has one root. So one root, one solution, so same. So this for this, the discriminant we know has to be what? 0. So first of all, you take your a, which is the coefficient of x squared is m. B is 3m, the coefficient of x. And c, the constant term, is just going to be 1. And discriminant, we know it is b squared minus 4ac equals to 0. So what is b? So this will be 3m all squared minus 4 times a. A is m. times c, which is 1, all equals to 0. So this is 9m squared minus 4m equals to 0. And here we can take m as a common factor so that you have 9m minus 4 is equals to 0. So it means m is equals to 0, or 9m minus 4 is equals to 0. And this simply means m is 4 over 9, or m is equals to 0. But now, if we look at this carefully, go back to the question. What do we know about quadratic equation? We know a quadratic equation in general form. The standard form is this one, right? And we have a condition that a cannot be what? 0. Because if a, which is the coefficient of x squared, becomes 0, it means we will no longer have quadratic. It will be reduced to a linear equation. So for that reason, we have to reject m. As you can see, this m is also the coefficient of what? Of x squared. So this has to be rejected. So you reject this. So the only solution here is m equals to 4 over 9. And that is the end of these questions. We've completed all the questions from 1 to 4. And I hope you enjoyed this video. Thank you for watching.